Good morning. Today we are going to start with section 6.4. We're going to cover section 6.4, trigonometric form of complex numbers. Notice that sometimes we're going to call them polar form, and that'll be on the next section. But in this section, we're going to call them trigonometric form of a complex number. So we're going to cover complex numbers, same thing that you guys covered in Algebra 2, but a little more depth. And please copy your essential question, glue your cutout, and then we can start once you're ready. So pause it if you need more time. So in this case, we have essential question: how do you plot polar or trigonometric points in the complex plane? So the complex plane and the vector representation. So one of the things that you guys will notice is that before you used to be able to plot complex numbers as just a point, we are going to actually write it down as a vector, similar to what we covered on the last section. Unlike real numbers, complex numbers cannot be ordered or in number line. So even though this is a complex number, it cannot be placed on the number line. It has to be placed on a complex plane. So we're going to modify your x and y plane as follows. Where we have your imaginary axis, that's your y-axis, and your real axis is your x-axis. So what used to be your x-axis now is your real axis, and what used to be your y-axis now is your imaginary axis. So therefore, whenever we plot the following point, -2 minus 4i, 2 is your real part, so therefore we're going to be moving to the right 2. -4 is your imaginary part, so therefore we're going to go 1, 2, 3, 4. And in algebra 2, you plot it as a point. And in math analysis, we're going to write down as a vector representation. And today I'm using my first ID that I had back from 2003. That's when I started at Santa Fe High School. And yes, I used to have some hair before. Now it's all gone. But anyways, so in this case, I'm going to write down as a vector. So I'm going to start from 0, 0 and go towards that location. Remember, it's 2 real, -4 imaginary. Now, we covered vectors on the last section in two different manners. So before, we used to have 2 comma -4, and that used to be a vector. And we remember that whenever we had that notation, that means that your starting point was 0, 0, your initial point, and your terminal point will be at 2, -4. 1, 2, 1, 2, 3, 4. Then we also wrote it down as 2i minus 4j, and we made those bold since those were vectors themselves. And now remember, one of the things that you want to be able to remember or to be able to understand is that whenever it's in that type of notation, the I is not the same as this I. This, and notice I placed it in bold, this is a unit vector. So this is 2, and I, your unit vector, is 1, comma 0, minus 4. And j is a unit vector, and that is your vector is 0, comma 1. Then we can multiply a vector by a scalar number. So therefore, 2 times 1 is 2. We just multiply each of the components. And 2 times 0 is 0. 1 place plus. Negative times 0 is -4. Since I'm going to, the scalar is a -4. -4 times 1, well, -4 times 0 is 0. -4 times 1 is -4. And now, things that you need to keep in mind is that 1, 0 is your unit vector, 1 to the right and stay there. 0, 1 is your unit vector, 0, 1. Now you multiply by 2, so it becomes 2 0. So therefore you multiply, just like we did in the last section, we multiply this by 2. So 1, 2. And we multiply this unit vector, your j vector, which is 0, 1, we multiply by negative 4. So instead of going forward, it goes back negative 4. 1, 2, 3, 4. And now we are going to add them. If you guys remember on the last section, when we add them, we either move this vector here, or we move this vector over here. And notice that whether we move this one here or this one over here, we're going to end up in the same location. So therefore I'm just going to move this vector over to the right. I'm going to place it as dash. Move that one down. I'm going to place it as dash. And this new vector is going to be called the resultant. Well, we usually don't take the time to do all of this work, right? We usually say 2, negative 4, 2 to the right, and down negative 4, and we end up with the same vector throughout. Each complex number a plus bi determines a unique position vector, OP, with an initial point at 0, 0, and the terminal point at AB. So therefore, we are going to write or treat complex numbers as the vector representation, where you start at the starting point and your terminal point, your initial point and your terminal point, where this will be O and this will be P. So we have the three type of representations that we have so far, and we are going to treat them the same. So the formulas that we're going to cover today are going to be very similar to what we cover on section 6.3. Example number 1. So take the time to write it down, and then we'll continue once you are ready. Great. Pause if you need more time. Find the sum of negative 4 plus I. The plus and 5 plus 2i. We need to be able to graph both complex numbers and then the resultant. So we want to be able to do it graphically first. I'm going to make a 5 by 5 graph. 2, 4, 5, 2, 4, 5. My first vector is negative 4 in up 1, where this is your real and that's your imaginary. My second vector is at 5, 2, 2, 4, 5, 1, 2. Then I need to be able to make a decision. So then I need to decide whether I want to be able to move this vector over here. And it has to be, remember, vectors can be moved around. They just need to be the same length in the same direction. Or if I want, I can take this vector here and I can move it over here. And notice that it'll be either one. So I can take this one and move it over here, and that's what I'll do. So therefore, I'm going to take that vector and I'm going to place it in red. To get to the vector, I went to the left 1, 2, 3, 4, and up 1. So I'm going to go from this point 1, 2, 3, 4, and up 1. Therefore, I just move that vector over here. And I'm going to do the same thing for this vector, or I can just connect them. Notice that either way is fine. I move to the right 2, 4, 5, and up 2. 1, 2, 3, 4, 5, 1, 2. It should always match. Now your resultant vector, so this is going to be your resultant. And this is negative 4 plus I. This is 5 plus 2I. And this is 1 to the right and up 3. 1 plus 3I. Or we can have done it algebraically. So you also want to go to do algebraically, negative 4 plus I plus the sum, 5 plus 2y. On the last sections, we covered that we can add the real parts, so negative 4 plus 5 gives me 1. We can add the imaginary parts, 1 plus 2 gives me plus 3i. And that should match. Now, your graphical representation is very important, and the resultant part, it's also very important as we go into the next sections. So make sure that you're able to graph it and you're able to move your vectors either here, over here, or this one up here, and you end up in the same location. Notice that the following formulas look very similar. Relationships among the x, y, r in theta. So x is r cosine, and that's from the last section. Y is equal to r sine of theta. R, your resultant, is equal to the square root of x squared plus y squared. Remember, r is basically just the length of the vector. What is the length from here to here? And it comes from the Pythagorean theorem. And your tangent is y over x. So let's just cover the concepts very quickly. If I make an x and y axis on the left-hand side, I won't spend too much time since we already did it on the last section. So if I have a vector, let's say, or a complex number in this case, if I have a complex number of 2 and 3i, then I'm going to, or in this case, let's go and work with x and y. So this is x and y. Let's make it more general. I'm going to make a perpendicular line with the x axis, making a right angle. So therefore, that's x, this is x, that is y, and this is your resultant. So notice that before on vectors, we used to call that magnitude. Now we're calling it a resultant. So therefore, to be able to find x, and this is your angle, to find x is your adjacent over your hypotenuse, so we use the cosine. To find y, it's going to be your opposite over your hypotenuse, so therefore we use sine, and we developed those formulas last time. To be able to find r, we're going to use your Pythagorean theorem since this is a right triangle. And the tangent of theta is your y over your x. So therefore, if I have x plus yi, I can replace my x with the definition or the value of x, which is r cosine, plus y will be r sine. And we should move the I to the very beginning or to the front. I'm going to take out the r, so that gives me common factor out the r, that gives me cosine of theta plus I sine of theta. And that is the definition that we are going to use. Now, sometimes you guys will see it in a shorter manner. So we have r, and instead of writing, because the angle will always be the same, since we were always working with the same angle for both, for the x and for the y. Therefore, we're going to write down r, and then we're going to write down CIS. And then of theta. So sometimes you guys will see it written down, or more often than not, you'll see it down in the shorter version, and you want to get used to that as well. So that will take us to the next cutout. On the next scale, we have the trigonometric polar form of a complex number. We're going to see it as follows. So take the time to glue it down, and then we'll continue once you're ready. So remember that is R is the resultant, cosine of theta, I sine of theta. So where R used to be before used to be your magnitude, now we call that resultant. Sometimes they call it a radius, but that will be on the next section. Or we can rewrite it as R cosine I sine. So cosine I sine of your angle. So those two expressions are equivalent. And now that's called a trigonometric form or polar form of the complex numbers x plus yi. So where before we used to have a x plus yi, and let's assume that we have, let's assume that's 4, 4, so we can actually have a bit more accurate. And we're going to say 4 plus 4i. Now we are going to have the same direction. It'll be in the 45 degree. Do you guys agree? It's halfway mark. 1, 2, 3. But it's not really 4. Now to be able to find the length of r, so this will be r cosine of theta plus I sine of theta. To be able to find r, we are going to use a formula, and we're going to be doing that on the next section. Right now, we're just going to place an angle, and it's about square of 32, which is about 5 point something. So 1, 2, 3, 4, 5 point something. So it's all the way over here. So in this case, it's going to have the same length. It'll be in the same direction, so it should be 5 point something, right? So it should be higher. You can see that? It should be 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 point something. And now we're not going to use this polar graphs yet. I kind of want to start introducing it as we go through the process, so you know that it's the same is 45 degree angle, and the length will be square of 32 that we're going to find how to find it. We're going to learn how to find on the next few examples. Example number 2. Express 8 CIS of 315 to regular form. In regular form. In rectangular form. So we're going to express 8 CIS 315 degrees in rectangular form. So first we need to be able to expand it. So we have 8, and this will be the cosine of 315 degrees plus I, the sine of 315 degrees. So the first thing that we're going to do, we're going to evaluate 315 degrees. So I'm going to place my x and y axis. On the left, do you guys know your cosine of 315 degrees? You should know at this point without doing the graph. Right? 315 degrees is here, halfway mark. So therefore your cosine will be your x value, which is square root of 2 over 2. So this will give me 8. The cosine of 315 degrees is the square root of 2 over 2 plus I. The sine of 315 degrees will be, if they're the same length, will be square root of 2 over 2, will be negative square root of 2 over 2. And now I'm going to distribute the 8. The 8 and the 2, I'm going to reduce it to 4. square root of 2 plus 8, and the 2 cancels out the 4, so it gives me 4i square root of 2, but I forgot the negative in there. So let me rewrite it. So it'll be 4 square root of 2 minus 4i square root of 2. Now be careful, there's going to be times that you guys will see it written down as either 4 square root of 2. They keep the I on the front before the 4. Sometimes you guys will see it written down as 4 square root of 2 minus 4 square root of 2, and then they keep the I on the very end. Either one is fine, depending on the book that you're using or depending on the section that you're working with. In this section, most likely you'll see it as this one here. But each one is perfectly okay, since all three of them are multiplying the negative 4, the I, and the square root of 2. They can be in any location, in any order according to the, which property will that be? Associative property of multiplication. Example number 3. Go ahead and take the time to copy it down, and then we can start once you are ready. Excellent. Pause if you need more time. Write each complex numbers in trig form. So now I need to be able to do the opposite. They give it to me in rectangular form, and I need to be able to rewrite it in trig form. So on this one, they give me in trig form, and I write down in rectangular form. So in order to be able to rewrite it in trig form, I need two things. I need to be able to find my R, my resultant, and my angle. So therefore, let's go and find both things. Find R, and then we're going to find the angle. To find R is the same formula that we covered before. So R is equals the square root of x squared, where is negative, this is your x, and this is your y. So it'll be negative square root of 3 squared plus, now be careful, your y is not your I, it's only the coefficient, so it'll be just negative 1 squared. So therefore R is equal, that square root and the square cancel, the negatives will be 3 plus 1, R is equal to the square root of 4, so therefore R is equal to 2. Now to find your angle, we are going to use your tangent of theta is equal to y over x, so it'll be negative 1 over negative square root of 3. So negative becomes a positive, so that gives me the tangent of theta equals, I'm going to rationalize my denominator. That gives me square root of 3 over 3. Now square root of 3 over 3 is one of the angles that you do know for tangent. So I'll place a x and y axis. Square root of 3 over 3, so it's positive, so it has to be either on the first or the third quadrant for tangent in order to be positive. And square root of 3 over 3, is that your 30 or your 60? Correct, that's your 30-degree reference angle. Remember, every time it's divided by 3 is your 30 degree. If it was just square root of 3, it will be your 60 degree, which will be here or here. Now, so it's going to be either 30 degrees or it's going to be 210 degrees. So therefore, this is negative and negative, so that's to the left and to the left. So your angle is 210. So theta will be equal to 210 degrees. And now that I found R in theta, I can rewrite it as R CIS of theta, which is 2 CIS of 210 degrees. Or if you want, you can write down in the longer notation, which will be 2 cosine of 30 degrees plus I sine of 30 degrees. And one of the things that you'll notice that every time we are writing down a complex number in trig form, those two angles will always be the same. So let's do the same thing for example number for letter B. I need to find two components. I need to be able to find R, which is your resultant, and I need to be able to find theta. In order to find R, I'm going to use my formula, R equals. Now, is -4 your X or your Y? That's going to be your Y. So I can rewrite it as 0 for your real number minus 4i. Well, I don't need a 0, but I'll just place it in here. 0 squared plus -4 squared. R equals 0. This gives me 16. R equals 4. And to find my angle, I'm going to use my tangent of theta is equal to y over x, which will be -4 over 0. So see if you can find the angle. What will be the angle that will give you -4 over 0? Go and pause it, and then we can continue on. Excellent. So in this case, it's undefined. Do you guys remember where your angle is undefined? Now, if you use a calculator, it's going to give you 90 degrees. But we need to be able to remember that undefined, it's either 90 degrees or 270 degrees. Either one of those two will give you undefined. And we can try on the calculator. So if I just type in the tangent of 90 degrees, that gives me undefined, math error. The tangent of 270 degrees will give you math error as well. Both of them are undefined on those two locations for tangent. So which one is it? 90 or 270? So in this case, it's 0 and -4, so we stay there and then we go down, so that'll be 270 degrees. So I can rewrite it as 4 CIS of 270 degrees. This notation will be fine, or I can rewrite it into the longer notation, 4 cosine of 270 degrees plus I sine of 270 degrees. Example number 4. Go and take the time to copy it down, and then we can continue once you are ready. So pause if you need more time. So I need to be able to find the product. Now, we don't know how to multiply two trig form complex numbers. So what we're going to do, we are going to rewrite them in rectangular form, just like we did on example number 2. And then we're going to multiply. So first I'm going to evaluate the cosine of, so we have 4. And what is the cosine of 120 degrees? So let's see, x and y, 120 is over here. Cosine is your shorter side, but let me just draw it quick in x and y axis. At this point, you should go to just visualize and know the value. 120 is up here. Cosine is your x value, so that'll be -1/2. Plus I, sine of 120 will be square root of 3 over 2. And we find in the product times. We have 5. The cosine of 30 degrees is over here. The cosine will be the x value, which is the longer side, so therefore will be square root of 3 over 2. Plus I. The sine of 30 degrees will be 1/2. I'm going to distribute my 4 to each one of them. So 4 times negative 1/2 will be negative 2. 4 times square root of 3 over 2, that 4 and the 2 are going to simplify to 2. So it gives me plus 2i square root of 3. I'm going to place my I in between. Or you can place it beforehand or afterwards, up to you. Multiply by, distribute the 5. That does not simplify, so it gives me 5 square root of 3 over 2. Plus, multiply the 5, so it gives me 5 over 2i. And in algebra 2, you guys learn to multiply this out. So therefore, we're just going to use the distributive property, multiply this out. Then we are going to use the distributive property to multiply the second part. Let me multiply it out. So therefore, if I multiply negative 2, my 2's are going to cancel out. So therefore, I'll just have a negative 5 square root of 3. I'm going to multiply this out. The 2's are going to cancel out again, so I have negative 5i. Next, I'm going to distribute this to both. So let's multiply those two expressions. That 2's are going to cancel out. So I have a I and a 5. So I have plus 5i. I have square root of 3 times square root of 3 will be square root of 9, which is just 3. I'm going to multiply this out. My 2's cancel out. So I have 5. I have I times I will be I squared. And I just have a square root of 3. Let me double check that part. So the 2's cancel out. 5. I times I is I squared. And then I have a square root of 3. Let me simplify this out. So therefore I can multiply 59. I know that I squared is equal to negative 1. So therefore I have negative 5 square root of 3. Negative 5i. That gives me plus 15i. That gives me negative 1 times 5 is negative 5 square root of 3. Now I can combine like terms, which gives me negative 10, and the square root of 3 stays there, plus 10i. Now, since we start with trig form, I need to be able to rewrite this in trig form as well. So now that I have this is the correct answer. So now I need to be able to find two things. I need to be able to find the r, which is your resultant, and I need to be able to find theta, which is your angle. First, let's start by finding r. We know that r equals the square root of x squared plus y squared. X is negative 10 square root of 3 squared plus y is 10 squared. R equals 100. So negative 10 squared is 100. Square root of 3 squared is 3. The square root and square cancels. And that gives me 10 squared is 100. So therefore that gives me 300 plus 100 will be 400. The square root of 400 will be 20. Find theta. To find that angle, I'm going to use my tangent of theta equals y over x, where the y is 10 and the x is negative 10 over square root of 3. My 10's cancel out. I cannot have a square root on the denominator, so I'm going to rationalize it. Since the square root of 3 is an irrational number, I need to only have rational numbers on my denominator. So therefore, I have the tangent of theta equals positive by negative. Let me not forget my negative. Square root of 3 over 3. I'm going to make a x and y axis. So let's say square root of 3 over 3 is one of the angles that we know. So therefore, that's negative, so it has to be on on the second or on the fourth quadrant for it to be negative. And square root of 3 over 3 is your 30-degree reference angle. So either here or here. So therefore, I need to decide which one is it. Well, I know that it's either going to be 150 degrees or 330 degrees. That's negative, that's positive. So that's negative and that's positive. And that's what's very, very essential for you to sketch it. So therefore it's 150 degrees. So I can rewrite this as your radius, which is 20, and CIS of 150, or you can rewrite into the longer form. And then I know that at this point you might be thinking, hold on, Diaz. Instead, can I just multiply 4 times 5 gives me 20? And I can just add 120 plus 30 gives me 150? Sure. So I could have just done that instead. I could have just multiplied my coefficients and added your angles. And instead of doing all that work, you end up with exactly the same answer. And that is what your theorem below says. So if you have two complex numbers in trig form, the way that you can multiply two complex numbers is to be able to multiply your resultants and add your angles. So you multiply by you add your angles. And you end up with the same answer. So in example number 5, which way do you guys prefer? You want to be able to convert them into rectangular form, then multiply it out, and then convert back into trig form? Or do you want to use the formula? Correct. So it's much easier, correct? Will be 3 times 4 will be 12. And it's going to be CIS. And in order to be able to find the angle, I'm going to have to add both angles. So we have pi over 4 plus 5 pi over 6. I need to have this in denominator, so multiply by 3, multiply by 2. That gives you 3 pi over 4 plus 10 pi over 12, which is, oh, I said 12. That'll be 13 pi over 12. Or sometimes you guys will see it written down in that longer format, which would be cosine of 13 pi over 12 plus I, the sine of 13 pi over 12. Example number 6. Now we're going to do the same thing with example number 6. And I know at that point you can say, well, Diaz, can I just use the cutout below? And tells me that I can just divide my resultants and then subtract. Sure. But on part of your homework, you will have to go through the multiplication with simplification. And I kind of want to walk through it and see if you have any questions. So copy example number 6, and then we'll continue in a second. So first, I'm going to pause it if you need more time. First, I'm going to take the time to rewrite it. So it'll be 2 times the cosine of 300 degrees plus I, the sine of 300 degrees, over 8 cosine of 240 degrees plus I, the sine of 240 degrees. And now I'm going to rewrite each one in rectangular form. So right now they're in trig form. I'm going to rewrite it in rectangular form. And I'm going to take the time to evaluate cosine of 300 degrees. So 300 degrees is, if I make it quick, x and y axis. 300 degrees is right over here. So the cosine will be 1/2 plus I. The sine will be negative square root of 3 over 2. Over 8. 240 degrees is right over here. So the sine will be negative 1/2. The cosine will be square root of 3 over 2. Now, if you don't have an exact angle that we know, so let's say they give you 230 degrees, then you just have to use your calculator and work with decimals. But most of the time, they'll give you values that we know because that way you can simplify much easier. 240 degrees will be also negative square root of 3 over 2. I'm going to distribute, so it gives me 1 minus. The 2's cancel out, so I have square root of 3. And let me place my I right before it. Over. I'm going to distribute the 8, so it gives me negative 4. The 8 and the 2 simplifies to negative 4I square root of 3. And I'll place my I between the, just like we've seen it before. And now that I have the rectangular form for each of the complex numbers, then I can simplify. Now I have a problem with my denominator. In order to divide, I cannot have imaginary or irrational numbers in my denominator. So I'll multiply by, do you guys remember, what should I multiply by? What is this called? Negative 4, and the only thing that will change is to a positive 4I square root of 3. What is that called? It's called the conjugate. And now I can multiply it out. So remember that you only change the second part. You don't want to change both signs because otherwise it's not going to cancel nicely. So let me make enough space. And now I'm going to multiply, distribute the 1 to both. 1 times negative 4 is negative 4. 1 times is positive 4I square root of 3. Go ahead and pause it. See if you can multiply the numerator and denominator, then we can check your answers. So got it? Let's continue. So negative times negative is a positive. We have a 4. We have to be careful. We have an I, and we have a square root of 3. And now I'm going to multiply negative times a positive is a negative. I have a 4. I times I is I squared. And square root of 3 times square root of 3 will be square root of 9, which is just 3. Now I'm going to multiply my denominator, negative 4 to them both. So negative 4 times negative 4 is positive 16. Negative 4 times positive will be a negative. 4 times 4 is 16. I have an I, and I have a square root of 3. Next, I'm going to multiply this expression by both. Negative 4 times negative 4 is positive 16. I, and square root of 3. So negative is positive 16. I square root of 3. And the last term, negative 4 times negative is a negative 16. I times I is I squared, and square root of 3 times square root of 3 will be just 3. Notice that on your denominator, this should always cancel out. But let's start with the numerator. We have a negative 4. We have, I can combine those two, so it gives me plus 8I square root of 3, since they have the same, they like terms. So I have I square root of 3. I know that I squared equals negative 1 times the negative is a positive 4 times 3 will be positive 12. On the denominator, this is 16. I have those two expressions should always cancel out. I have I squared is negative 1 times a negative gives me a positive 16 times a 3. Which will be 48. So my denominator is 16 plus 48 will give me 64. I'm going to add my real parts on my numerator. That gives me a positive 8 plus 8I square root of 3. When we have a complex numbers in algebra 2, remember that you have to separate them. So you have 8 over 64 plus 8I square of 3 over 64. I can reduce it by 8, so it gives me 1 over 8 plus 1 or just I square of 3 over 8. So this will be your answer. But just like on the last one, since we started with trig form, guess what? We're going to rewrite it in trig form. So one of the things that I do, I actually factor out the common factor, 1 over 8. And 1/8 multiplied by 1 and 1/8 multiplied by positive I square of 3. That way I'm working with a smaller version of this expression. So therefore I need to be able to find two things. I need to be able to find R, and I need to be able to find theta. R is your resultant, so R equals the square root. I'm only using this part, y and this is x and y. So this will be 1 square plus the square of 3 square, not the I. So it gives me R equals 1 plus square root and square cancels, so R equals 2. And to be able to find your angle, will be tangent of theta will be y over x, so it will be square root of 3 over 1, which is square root of 3. Now, I'm going to make it x and y axis. Do you guys remember what should be your angle in this case? Square root of 3 is positive, so it should be on the first or third quadrant. Square root of 3 is your 60 degree. In this case, this is positive and positive, so positive and positive, so it should be 60 degrees, not 240. So theta equals 60 degrees. So now I can rewrite it as 1 over 8, and R is 2, and CIS 60 degrees. I can reduce 1/8 times 2 is 1/4. CIS of 60 degrees. And you know, some of you guys might have said, well, hold on, Diaz, can I just have done that instead? 2 divided by 8 is 1/4. 300 minus 240 is 60. And that is what the theorem, which is your last example for today. The theorem tells me that I can divide and subtract my angles. And if you guys can fix this, this should be it too. Go and copy example number 7, and then we'll continue. Excellent. So in this case, do you guys prefer doing it the shorter way, or rewriting it in rectangular form, multiplying it out, and then change it back to trig form? Correct. So much easier. 10 divided by 2 will be 5. CIS. 150 minus negative 60 will be 210 degrees. And that's it. So that is the lesson for today. Have a great day, and email me if you have any questions. I'll see you guys next time.